A bucket with liquid fuel is thrown on the fire to increase intensity and difficulty of suppression. This is a live burn demo by Blanchett Manufacturing to illustrate CAFS effectiveness with limited manpower and water. When the fire is suppressed, the white smoke billowing is steam. The fire in the first car never reignites due to a thick blanket of foam smothering and cooling the fuel. The actual suppression time of this car is approximately 10 seconds. Firefighter is now overhauling to prevent reignition. In the car fire demos, the fuel load, besides the interior itself, was as many tires as could be packed inside. Tires were chosen because they create an intense and difficult fire to fight. The fuel load was burned for approximately 10 minutes before liquid accelerant was added to intensify the fire load. When considering a CAFS system, there are 5 major considerations: user-friendliness, maintenance, reliability, confidence, and cost. User-friendliness. Anyone can be taught how to operate the row equalizer CAFS system in approximately 1 minute. Maintenance. Check the oil level in the oil compressor by checking the sight glass and pulling an oil sample once a year. Reliability. The equalizer carries a lifetime warranty. Confidence. No moving parts, springs, balancing valves, or electronics to break and wear out. Cost. The conservative side of CAFS is 10 times over water. A 400-gallon tank becomes 4,000 gallons. A 70-gallon per minute nozzle becomes 700 gallon per minute. This does not take into consideration the suppression side of CAFS.
Here at Blanchett Manufacturing, we spent quite a few years researching CAFS systems. What we was looking for is basically something that you would use. It's got to be simple, it's got to be reliable and durable, and then the maintenance in there. All the systems that we had been looking at had none of these features in there. So up to 4 years ago, I refused to put a CAFS system on my truck. We was getting rejected on bids because I would not put CAFS system on a truck. The reason for that is, say I sold 100 trucks. If you have a problem with it, you're not going to go to the manufacturer that built the CAFS. You're going to go to the truck manufacturing to get your answers answered. So I would basically turn into where I would be on the phone continuously trying to answer the problems with the systems we're having. The row equalizer eliminated this. Now let me back up and explain what made it so difficult. Okay, to create CAFS, we got to have a water solution, a water soap solution, basically about a 1% or 0.5%, whatever you set. Okay, how you make that solution doesn't make any difference. You can batch mix it into the tank, or you have a foam injection system. Then the next processor we got to have is air. Okay, you accomplish this by a compressor system. Okay, now let me explain the real problems here. How many gallons of water can we put in a 5-gallon container? Basically 5. What if we put it under 2,000 pounds of pressure? Maybe 5 and a pint into this container. Okay, we've got this container, it's got water under pressure. Now we have another container, 5 cubic foot. How many cubic feet of air can we put in this 5 cubic foot container? Put it under 2,000 pounds of pressure or whatever. Okay, now here's where the problem becomes. Put a valve on both of them. Open the valve. What happens? The water instantly goes to 0. The air starts blowing off, the pressure slowly comes off, plus how many cubic feet. So now remember, we've got to get the air pressure and the water pressure exactly the same to get them to come together. Once we get them together, then we have to measure it. 1 cubic foot of air, 1 gallon of water, or whatever mixture you're wanting to do. Once we get them together, then we got to scrub them, put them together and scrub them. Okay, all these processes become very difficult. That's where everybody else has used pressure regulators. They have a multiple regulators, balancing valves, springs, so on and so forth. So what the row system has done here is basically done it by physics. With this equalizer, It's done it with a physics system. Now, if somebody wants to know a little further on that, you'll contact me and I could explain in a little more detail exactly how it works, the system in there. But this system, this is another thing that nobody else has. It carries a lifetime warranty. When a fire department chooses a CAFS system, there's 5 major issues that you have to really look at when you do it. Number 1 is user-friendly. If it's not user-friendly, you're not going to use it. Because when the stakes are high, the pressure's on, it has to be a very user-friendly system. Okay, right behind that is reliability. Is this system going to work? And reliability and trust basically come together. If it's not reliable, you're not going to trust it. So when I'm grabbing this system and pulling it off, I've got to rely on this and I got to trust it's going to come on every time. I talked to Mr. Rowe and he said in the 10 years he's been producing this, he has not had one failure, not one. You know, when you sit there, if you got water pressure with solution and you've got error and you turn them on, open that valve, and it comes to this system, guaranteed CAFS, no questions asked. Maintenance. The maintenance on this system, I went to the CAFS symposium and went into the class on maintenance. We're in there for 2 hours explaining the maintenance on some of these systems. The maintenance on this system, I'll sum it up in about 30 seconds. Check the oil on your air compressor, and that's it. That's the maintenance of this system. Cost is your last issue. The cost of the system, is it justified the cost? That's where you will have to do your own studies and figure out, is it worth your cost? Since I started using this system and fighting fire with it, I think it's almost a slam dunk on the cost, because basically I'm taking this water in here, this 400 gallons of water, and I'm putting out more fire with 400 gallons in a lot of scenarios than you will with 4,000 gallons. Another issue, when you start pumping a massive amount of water, you've got an EPA issue there. That water is coming off that fire and it's washing the chemicals out and everything else. Remember, you got to catch that water now. Okay, with CAFS, there's no water and no runoff. It's staying right there in the car. And in most cases, when I do them live burns, the CAFS I shoot inside that car never comes out. I have absolutely nothing underneath that car, no oil, no residue there. So basically, another issue is the EPA issue in capturing the water you're doing. Okay, let me demonstrate the simpleness of this. As I'm exiting the truck, I'm going to set my emergency brake. Then I'm going to come down here and I'm going to turn on my air compressor. Okay, pull my CAFS line. In this particular scenario, what I'm going to do, I'm only going to use 50 feet of line here. The reason for that, a lot of systems use at least 150 to 200 feet of line to scrub it. You come out, start your pump, foam injection system, set your percentage about 0.5% to 3/4, full throttle, charge your line. Okay, the one beautiful thing about a CAFS system, you can't water hammer the line. Once you've charged this line, I'm going to talk about 2 different systems. The row system, which we have on this truck, and the other systems as do's and don'ts. And this system breaks all the rules on the do's and don'ts. It's got its own rule book. The rule book basically is use your nozzle, period. Okay, rule number 1 on other systems. When you first open this, you're going to have chucking, you're going to have a surge and everything else until that system gets itself balanced. On this particular system, I'm going to have a small charge of air because of the air in the line when I charged it. Then I'm going to have a real slight chuck of water, or it isn't really a chuck, it's a surge of water, maybe a gallon, because the air will not come on until it has water pressure to hit that 80 pounds of pressure. Okay, here's my air chuck. See, there's my air chuck, there's that water, and now here's the CAFS. Okay, now, here's the do's and don'ts. On other systems, you open them up and you leave them run from 10, I've seen up to a minute for the system to get itself set until it starts doing a good CAFS. Now think about it, 10 seconds to a minute. 10 seconds is 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. Now you got CAFS, a good CAFS. This system, open it, I got CAFS. Another thing you don't do is open close, because when you're opening and you're closing this system, your valves, all your pressure regulators and stuff are having to readjust and try to figure out what's going on here. And also, you open it all the way. Okay, this in here, I can open, close, open, close, open, close. Okay, say I don't want a full bore. Crack it. I don't care. Full bore. Shut it off. Crack it, crack it, crack it, crack it, crack it, crack it, full bore. It doesn't make it any difference. That's where the user-friendly, the trust comes in here. Another feature we have in this thing is called full flow. What we can do is open both valves. It's going to make a very wet, soapy solution, but will produce over 125 gallons a minute out of this line. And that's the reason this rule came in by NFPA, because over 50% of the time they charge the system, it didn't work. When you go up to a burning building, by George, you better have some fire suppression somehow. This system, so to meet NFPA, you open both lines up and just shut your full flow off when it starts flowing. There's no questions asked. But when I do all my basically demos and stuff, I never open my full flow. My flow is not open at this point.
The addition of fuel in the beginning enhances the fire load severity. This demonstration proves the capabilities of the CAFS system with a one-man crew fighting a multiple vehicle fire. At this point, the firefighter has taken control of the first car. The firefighter has now taken control of the second car. The scene is under control and the firefighter begins to overhaul. This 3-car fire is extinguished with less than 100 gallons of water in approximately 1 minute. By using minimal water, there is no runoff to create a larger environmental hazard.